M and N be any two 4 by 4 matrices with integer nt satisfying Mn equal to 2 times this matrix, then maximum values of determinant sum, determinant m plus determinant n is, we have to find sum of determinant is of matrices M and N, and we know that product of determinant Mn can be written as 2 times this matrices, and if you focus on this matrices, all diagonal elements are 1 and some non-zero entries upper principal diagonal, so it is upper triangular matrix, and when we multiply scalar 2 in this matrix, then 2 will come at diagonal position, so it will be upper triangular matrix, and we know that for upper triangular matrices diagonal elements are eigenvalues, so its eigenvalues are 2 2 2 4 times, means algebraic multiplicity of 2 is 4, so its determinant of mn will be product of eigenvalues, it means 16, and you have to tell about determinant of m plus determinant of n and its max value, possible max value, and we know that determinant of product can be resolved individual product determinant of n into determinant of n, it means 16 can be written as possible choice of 16 is 1 into 16, 2 into 8, 4 into 4, and some maybe other. So if you add these, suppose matrix M has determinant, matrix M has determinant 1 and one matrix N has determinant 16, then its sum, because we need to tell about sum of determinant of M plus determinant of N. Determinant of M is 1 and determinant of N is 16, then or anyone can take determinant 16, either M or N, and other one will take 1, then their sum will be 17. So this is max value, because 2 and 8, if determinant of m is 2 and determinant of n is 8, then their sum will be 10, so it's not max value, we need to tell about max value as question asked, and in other case also, so max value of this is 17.